a few minutes looking at a value called pi, and it's written as the Greek letter for p, and so the lowercase p, so the way you write pi is like that. And pi is a value that you will come across in geometry quite a lot, especially when you're looking at circles or globes or spheres or cylinders and structures like that. So, what is pi if you haven't come across it or if you're unsure? Well, let's take the simple case of a circle. So, this is a circle with my wobbly drawing on top of it. And a circle has certain dimensions to it. One is circumference, and circumference is what I've just drawn out, so it's this outer line here. And in when we were looking at squares, we called this outer bit the perimeter. So it's similar to that. And then in any circle, there's a central part over here. That's the middle of the circle, which is that point. And so that's 0 on this diagram. And from the middle of the circle to the perimeter, to the circumference, this is called the radius. So here it's down as r. It can be the lowercase r as well. So this is the radius. And then if you were to bisect the circle right down the middle, then that length, that line, would be the diameter. Okay, so make sure that you know what each of these is because they're going to be useful to you. So you have a circle, and the outer bit is the circumference. Then there's the middle bit over there, and then from the middle bit out to the circumference, the radius, and then right across that, then the diameter. So where does pi come into all of this? Well, someone worked out a long time ago, if you have various shapes, and the circle is a very common shape, and you want to work out mathematicians and engineers and all wanted to learn about this because very important in building structures and all sorts of things. And they worked out that if you drew a line right along the edge, the circumference as we know it now, and then open that line up. So, for instance, if we were to put a piece of string or something and just lay it down on there, and then open the string out. So this is the string from just one of these bowls, in this case, these circles. Then people found that when you opened it out, it's spanned over 3 similar circles. So that's quite surprising for some people. When I first came across it, I was thinking, gosh, that seems an awful lot. That such a long piece of ribbon can go along the perimeter, can go along the circumference. But can you see that it's just over? So 3 would be there, and there's a little bit over here and a little bit over here. And so pi comes from the circumference, the outer bit, divided by the diameter. So if you were to have measure the circumference divided by the diameter, you get a value which is just over 3. In the ancient times, people just refer to it as 3, but now it's usually something like 3.142. It does go on, and I'll be saying a little bit about this later. Notice that there are no units at all. So if we were to be measuring the circumference in, say, centimeters, and the diameter in centimeters, you can see from this equation, that they cross out. So these two cross out. and so there are no units as such. Um, and it has various interesting things. And if you have time, I think it's worth reading up about the history of pi through all the ancient civilizations. So just a few things for now. So pi is used when calculating the size or the shape of a circular object. And it can be flat like a circle, or it can be solid like a globe of some sort. Really interesting thing about this, if you're into it, let's just move this down so we can see this, is that um, pi has a constant value. It always equals this amount, and it doesn't matter how big the disks are, so it can be planet sized. And if you were to put the perimeter of a planet and then stretch that line out, it would be over the diameter of 3 planets. Or you can have little sources, and if you stretch that out, it would span across 3 little sources. So this is a constant value, and that's why in formula and when we talk about it, we don't say it's 3.142, we just call it pi, and then we understand what that value is. So constant value, it has no units, and you might be wondering where pi actually comes from. Well, it's the Greek letter for p, and it was taken from the first letter of the word perimeter. So pi is really p from perimeter. You know, a quite interesting thing about this, if you're into numbers, is that it's an irrational number. So whatever the measurements, whatever the size of the circles or whatever that you're measuring, when you divide it by the diameter, you get these numbers, but then the numbers carry on. It carries on, and no one has found where it ends. Indeed, if it ends. So I've written down here that I was researching this, and people have worked it out to 100 trillion places. So those are 100 trillion numbers after this, and it just carries on and on. By the way, the number at the 100 trillionth position was actually 0, but after 0, other numbers came. So no one has actually worked out if it does end or not. But we don't need that sort of precision when we're going to do the calculations that we're doing. And this gives you some idea of where we use, where pi is used. So let me just bring down the pen. That's it. So here are some formulae that uses pi. So when we're trying to work out the circumference of a circle, then as we saw above, pi equals the circumference over the diameter. And then you can rearrange this, so you can have, if you bring the diameter, if you get rid of diameter here, move it up here, then you have pi times diameter, which is d, equals the circumference. And then if you change it all around, then you get this formula here. So if ever you're trying to find out the perimeter, the circumference of a circle, you can measure the diameter, which is easier to measure, and then multiply it by pi. How about the area of a circle? So we have a circle, and we're trying to find out what the area is. If you remember, with a square, or a rectangle, Um, we found one side and then the other side, and so the area would be x multiplied by y. So that was for a square, so I found the area. For a circle, the way you find it out is pi multiplied by the radius squared. So we know what pi is. You measure the radius, or you get it from dividing the diameter by 2. Then you square it, multiply by that, and you've got the area. So these are formulas that are worth remembering. So that's a flat circle. How about the surface area of a sphere? And the sphere is like a globe, so that is 3-dimensional. And although this formula might look a little bit complicated, all you're doing is getting multiplying pi by 4, and then multiplying it by the square of the radius. So it's difficult to draw a sphere like on a 2D thing, if you can imagine that as a globe. So that's the surface area of it. How about we're trying to find the volume? So for instance, like it might be a football or something like that. You know, how could we find the volume inside it? How much air or whatever is inside it? Well, there's a formula for that. So the volume of a sphere is 4/3 pi r cubed. So r2 to the 3. And you think, oh my goodness, there's a lot of things to remember. But as you're using it, you remember these sorts of things.